Alright, here's my example of alpha decay. So I decided for this example that I would really count out the right number of protons and neutrons. Alpha decay, as I said before, happens to nuclei that are too big. So here's an example of a nucleus that is too big. This one has 235 M&Ms in it. So 235 protons and neutrons. So I write 235, that is A, a total. I counted out, when I put this together, I counted out 92 protons, so I call Z 92, and N must be A minus Z, because Z plus N is A. So what is left over must be 143 neutrons. Okay, so I counted them all out, I put them together, and here's my model of this nucleus. Now I look up in the periodic table. The number I'm looking for in the periodic table is Z, and I find on the periodic table that Z of 92, that's an atomic number of 92, is uranium. U is the chemical symbol, and we call it uranium. You probably heard about uranium a lot in the news lately because the country of Iran is trying to make nuclear weapons, and they need a lot of uranium in order to make nuclear weapons. So uranium is real important for nuclear energy. Uranium then, here's the uranium nucleus. There's also uranium inside the Earth, which is warming up the Earth by its radioactive decay. So I want to show you how the alpha decay of uranium works. Now this is uranium, a specific isotope of uranium, and we call that 235. So we write the number of A, the value of A, the upper left of the chemical symbol, to tell you how many particles are in that nucleus, how many protons and neutrons are in the nucleus. Okay, so when an alpha decay happens, an alpha particle must come away. What is an alpha particle? Well, an alpha particle is this thing, a helium-4 nucleus. And that nucleus has Z equal to 2 protons, N equal to 2, it's 2 neutrons, and A equal to 4. That's why we write the 4 up there. The Z equals 2 is something we can look at the periodic table, that's helium. So if I split those off, then what am I left with? The daughter nucleus, this one is called the parent. So the parent nucleus is uranium-235. The daughter nucleus, which is what's left over after the alpha particle is split off, must have different values than these. So the helium-4 nucleus took away 2 neutrons and 2 protons. So all I have to do to find out what the daughter nucleus is take 2 away from Z, right? So I must have 90 protons left here. I know that I also must have 143 neutrons left here. Oh, sorry, 141 neutrons left here. So 90 plus 141 is 231. And if we look on the periodic table, we find that Z equal to 90 corresponds to the element thorium, and so this isotope would be thorium-231. That is the daughter nucleus. So uranium splits into thorium-231 and an alpha particle. Splits apart into those two things.